Lecture 3, Forecasting, Section 2 and Part 2. In this part, we will have the time series with the seasonality. So a seasonal series is defined like this. A pattern is repeated every n periods. So yeah, if we have a pattern and that pattern is repeated every n periods, then we'll say that we have seasonality here. We have seasons, and the length of the season is that n periods. Okay, so for example, if you take a look at this time series here, as you see here, this pattern is repeated every let me show with different colors. Yeah, every n period, right? And the other one, see? So the number of periods here is 5, right? Every 5 period, yeah, every 5 period we have similar patterns, right? So if we have this kind of behavior in our time series or data series, then there is seasonality, and we need to take into account the seasonality impact in our forecast. Okay. There are several methods to show the seasonality, but one of the most common ways here is assuming a set of multipliers CT, and we should have this condition here. Sum over CT should be equal to n. Okay, and yeah, CT are defined as seasonal factors, and the definition of the CT is the average amount that demand is above or below the average in period T of the season. So yeah, we will have an average over a season, and then a demand in a particular period in that season could be above or below the average. So if CT is a number higher than 1, this means that the demand in that period is above the average. If it's lower than 1, then the demand in that period will be below the average. Okay. Here is the procedure for calculating the seasonal factors. At first, we calculate the sample mean of the entire data set. And then we'll divide each observation by the sample mean, and then we'll take the average on the data over the like periods in a season. So yeah, by having that, we'll have at the end the seasonal factors. Let's have an example here. We have the number of cars, let's say sold cars in thousands in the days of the week: Monday, Tuesday, Wednesday, Thursday, and Friday. And we have the data for the past 4 weeks. So here we are going to assume that we have a seasonality behavior over the days of the week. So each week will be assumed here as a season. Okay. So at first, we need to take the average over the entire data set. So here we have 20 data, and we take the average over all 20 data. It will be 16.425. Okay. And then we will divide each observation by the sample mean, and then we'll obtain these numbers. And now if we take the average for the data in the like period, this means that in period of Monday, let me show it. Yeah, for Monday, if we take the average over these data, we'll obtain 0.98. Okay, and then the average over the like periods, I mean on the Tuesdays, then it will obtain this number. So this means that, as you see here, Monday and Tuesday have the demand lower than the average in the week, but in Thursdays and and Fridays we have demand above the average of the week. Okay, so these numbers here will be our seasonal factors. Okay, seasonal factors, and if we add up these numbers, it should be equal to 5 because the length of the season is 5. We have 5 periods in a season, which is a week here. Okay, now if we multiply the average of demand over a week by the seasonal factors for each day of the week, then we'll have the forecasted demand for that day. Okay, for example, for Monday, the seasonal factor is 0.98 and the total average is 16.425, and if we multiply this, we will obtain 16.1 as the forecasted demand for Monday. And if we do the same for all days, we will have the forecasted demand for the days. So as you see here, the Monday demand is so close to the average, so we'll say Monday is an average day in terms of the sales volume. But Tuesday is the lowest day, and Wednesday again is lower than the average. But in Thursday and Friday we have sale above the average, and Friday is the highest volume of demand day in the week. De-seasonalizing a series, usually when we have both seasonality and trend in a time series, then we need to remove the seasonality first in order to have a data series with trend but with no seasonality factor. And then we can use the appropriate methods like regression or Holt's method to obtain the forecast. And after having the forecast value, we can multiply the seasonal factor in order to have the forecast with seasonality at the end. So this is the approach that we are going to have in this part when we have trend and seasonality. Okay. So here is the procedure that we will follow, assuming moving average. So the first step, observe the data pattern. So we'll see how many seasons do we have in the time series and how many periods does each season have. Okay, and then we'll build a table which rows are the periods of the seasons and the columns are the last M observed seasons. So here, since we are assuming the moving average, so this is why we are assuming M last seasons. Okay, and in step 3, we'll calculate the seasonal factors for each period of the season by the same method that we had in the previous slides. And then we will, at step 4, we will de-seasonalize the demands by dividing each observed demand by the seasonal factor. Now we have a de-seasonalized time series. It may have trend or it may be stationary. So since there is no seasonality, we can consider the appropriate forecasting method. It could be moving average, exponential smoothing, or regression, or linear regression, or the Holt method. And then by providing the forecast at the end, we include the seasonality at the end by re-seasonalizing the forecasted series by multiplying those forecasts by the seasonal factors. Okay, let's have an example here. The first step is observing the data pattern. So as you see here, this pattern is repeating in our data series. So as you see here, we have 2 seasons, and each season includes 4 periods, right? So the n here, the number of the length of the season will be 4, and we have 2 seasons here. Okay, so we can build our table like this. So we'll have 2 seasons in the columns, and the rows will be the periods in each season, and these are our original data or observed demands. Okay, so so we take the total average on entire data set, and as see here, it will be 20 for our example. Okay, and then we'll divide each observation on each observed demand by the total average. So we obtain these numbers here, and then we take the average of the data for each period. So, and then they will be the seasonal factors. Okay, so yeah, this is how we obtain the seasonal factors, like the example that we had in previous slides. Okay. In step 4, we de-seasonalize the demand. So here we have the 8 periods, and these are the original observed demand, and this column is our seasonal factors. So we have the seasonal factors here, and then if we divide the observed demand by the seasonal factors, we'll obtain the de-seasonalized demand here. Okay, now we have the de-seasonalized demand, so we have a time series with no seasonality, but there may be trend or not. So here we apply the linear regression to forecast the de-seasonalized demand for the future periods. Okay, so by having the linear regression at the end, we'll have this linear function here, and by having this, we can just put the value of t, the number of periods, as 1, 2, 3, and 4 for the 4 periods in the next season. We can forecast the demand for the de-seasonalized demand for the next season. Okay, so as you see here, we have done this. So we have the periods 9, 10, 11, 12 as the 4 periods in the next season. So, and by using the linear regression, we obtain the de-seasonalized demand for the 4 periods in the next season. And now, if you want to include the seasonality as well, so we need to multiply these de-seasonalized demand by their seasonal factors. Okay, and if we do this at the end, we will have the forecasted of actual demand with the seasonality. Okay.